morning, dear industry leaders. I am Sunil Pawar. I am part of Dassault Systems. We are here along with our partner, that is Solis Technologies. We'll briefly touch upon a concept and we'll see how it works in the new age of manufacturing. This again is not an industry specific sort of a concept. It can be applied for automotive, it can be applied for biofuel manufacturing, for example, or even battery cell chemistry. So what we are talking about here is manufacturing 5.0. Today is a sort of an age in which we have already touched upon industry 4.0, which is the whole cyber physical system. It started with the whole steam engine, which we call as the first industry revolution. Then the second stage came when electricity was introduced. The third came when the basic sort of automation was laid on. Also, it all sort of had a business process impact in which assembly lines were introduced. Industry 4.0, we can tell, is more about cyber physical systems. Now we are talking about a revolutionary shift. We are sort of bringing human back into the picture. Our previous speakers already talked about collaborative robots. So the human is coming back into the picture. Sustainability is coming back into the picture. So as we speak about industry 5.0, the progress cannot leave human out of the picture, and this collaboration between cyber physical systems and humans is what we are terming it as industry 5.0. So hence we are calling it as a revolutionary change, hence the word metamorphosis. And we are speaking about seamless execution across the value network because it is a concept which is no longer sort of restricted to a factory. It is across the value network. So this is a often sort of quoted term or a sentence, but the speaker remains anonymous. Is most of the problems, or rather what we call as problems, are basically symptoms. All of us are freshly out of a pandemic in which the same fear, or rather the fear of fever, the same fever what we had it, the root cause was entirely different. It was a novel coronavirus, a problem which was unknown, but the symptom was very known. So we do not treat the symptoms as a doctor would call it, we treat the problems. So how do we sort of extend that same medical diagnosis philosophy to an enterprise, to a factory, or to a business? So the symptoms are sort of shown here. So delivery failure, a customer sales order which is not getting delivered as promised is a symptom. Or stock out, warranty claims are too many. The cost is through the roof is a symptom. But what caused that is a set of problems. The problems again are sort of defined here at a very high level, but you can sort of do a deep down. The whole 5 analysis, the root cause analysis basically can be done at a system level. And we'll see how it can be sort of done in a very deep manner. So this is a score model. This is again industry wide what is adopted. So we typically see, so plan sort of runs across. We are at the center. Me, my company, my factory would be center of this particular model. On the left hand side you will have the suppliers and suppliers. So the way you have an automotive OEM, for example, you have a tier 1, tier 2, and the basic sort of the mother industries would be at this particular end. For example, chemical industries or oil and gas or even agriculture would be the first industry that typically starts with the raw material that we are producing. But we are at the center of this whole picture, but we cannot ignore both sides. On your left hand side is what we have the suppliers, the supplier of suppliers. On right hand side you have your customers, and the customers would eventually serve someone which is the end consumer, a person like us. So we cannot sort of ignore the entire value network as we call it. So the material flow typically flows from left to right, but that again is changing a bit. Not every manufacturing scenario would have that kind of thing. Since today is Friday and it is very close to beer o'clock, for example, beer you would have return logistics. The beer kegs, cans, what you have would also come back to the manufacturer. So material flow again not only flows from left to right, you would also have return logistics, say LPG cylinders. Information flow, typically it is what we know, what we have seen previously, flows from right to left. The end consumer, the final user of a passenger vehicle, the final user of a tire or a mobile phone, ultimately generates the demand, what everyone is serving. Information flow, again in today's term, we would say it is largely interactive, collaborative. So information flow is most important. If you see a typical vehicle manufacturer, most of the innovation is happening in the software side. The information side, the telematics, everything is being connected. It is no longer in the IC engine or the auto components and such. So information flow is the key. If we really have to graduate ourselves into this age of manufacturing 5.0, we feel information flow is very important to consider in the transformation. So again, collaboration across value chain. So the previous sort of graphic talked about a large kind of a block diagram, but right now we are diving in deep. So we are going to a process level. And each of these steps, as you see, so there are both internal to organizations. So these are your teams, be it supply chain, be it logistics, warehousing, production, everyone. And there are external parties, be it as a customer or a supplier who is part of the game. So here you see that the firm demand, everything comes from the customers. There are sales team who eventually get the orders, promise a delivery date, promise a certain spec. Then there is supply chain. So this is a particularly, what to say, a highly pressurized set of people these days, leading to many sort of heartburns. But supply chain ultimately has to serve both the customers as well as the factories. And these are the people typically over the past 2-3 years have been in tremendous amount of pressure. Then we come closer home. So now we are moving back to the factory, in which there is material planning. There is, you have to sort of ensure what you have delivered or a delivery which is promised to a customer has to be fulfilled internally. What do I need in order to produce the required finished good? So material planning is important. Production planning is important. What to produce, how to produce, in what particular shift. So both, so material planning would typically have a slightly longer kind of a horizon, but production planning typically would work across shifts and smaller time horizons. Then production execution, the actual build of the product together. Again, so this is not automotive, this could be an industrial equipment, this could be tire manufacturing or even chemical for that example. So here where that 4M that we discussed previously, the traceability is getting captured here. So we cannot have traceability if the data itself is not captured. The whole adage about what cannot be measured, what cannot be tracked, cannot be improved, that's the whole basic that we are coming about. So again, supplier and external party is coming into picture when it comes to material planning. I cannot sort of build or produce a certain part unless my supplier also is part of the value network. He himself does not fulfill his promises. How will I sort of keep up to what I have promised to my customer? So all of these steps, again, they are very simplistic. All of you are industry leaders, you would know that made to stock is different, assemble to order is different, made to order would be different. So this highly simplistic kind of a process grossly sort of gets overcomplicated as we walk through the paces. So this is what we are talking about, is that idea about connected enterprise. So it is no longer a highly intelligent system, but a system of systems kind of an approach. And we are talking about Dassault systems solutions here, but you could have a range of other systems which could be connected. So now this typical enterprise solution architecture, it is again shown as a set of block diagrams. So all your machines, SCADA, PLC systems, every sensor which is out there, every motor actuator which is out there is on the green block below. And then there is what we call as manufacturing operations management, that system. So here we have written about Dassault systems as Delmi Aprizo, but you could have any other particular product. Over here again we feel business process management as a platform. So we are no longer force-fitting a particular software solution into a business process. We are creating it ground up. What does the business process need? If there are 5 steps needed, 6 is an option. We create that business process layer as a start, then we configure the particular system to that particular need. So it is no longer a software product which is needed, it is a highly customized software solution. Hence the blueprinting is very important. So this particular layer is sort of in between the ERP layer and your operational technology, sensors, actuators, which are down below. Your ERP system, typically SAP would this sort of fall into this particular block. Again, we are not talking about replacing the ERP. We are wanting to keep it as a center of this whole solution architect, sort of extend its functionalities, but leave the core strengths of ERPs like transactional, financial accounting, cost management. We leave it best to ERP because that is where the strengths lie. On the left, what you see is product lifecycle management. You could have APQP, PPAP. So this is basically the design backbone of the whole. So how many variants are running? Is it a hybrid model? Is it a strong hybrid? Is it a weak hybrid? Is it a pure IC engine? That kind of variants would lie here. And this is the new product development. Basically, you could have a design set of software. You could have project management, APQP, PPAP, everything which is done here. So the work instructions, basically when you are designing a new product, the work instructions what you set here eventually follow to the manufacturing layer. So this is closest to the shop floor. This is the shop floor, and whereas this is on the design team. So work instructions, if you see here, or the manufacturing BOM is flowing from this PLM, this particular design powerhouse, to the MOM system. And then again, the accounting, we leave it to the ERP systems. So the part consumptions, the backflush basically happens from the MOM system, manufacturing operations management, to the ERP. Then we have the puzzle solver. So Eliyahu Goldratt's the whole example of theory of constraints. So this particular software suite, again, it could be SAP MRP. Over here we have written about Dassault's Autumn's product, which is basically a planning puzzle solver. You could have a set of constraints. So certain constraints could be hard constraints. So a delivery date which is promised. Whatever I could do, that is a constraint which cannot be breached. But over time is a soft constraint, it can be breached. So all those logics basically you can set over here. The output would be a production schedule. So this particular software would give you the planning as well as basically MPS, master production schedule, and the final who has to work on a particular production line, on which product, on which particular machine, using what method, what SOP. So this is that puzzle solver. So basically using these blocks, then ERP as a center, the design, project management, product lifecycle management on the left, the manufacturing operations management. So earlier used to be called manufacturing execution system, MES, but considering the warehousing, quality, this, if you really consider one system on the shop floor, we are expanding the breadth of this particular system. So it is manufacturing operations management, what we typically call. So this basically completes the picture. And again, this is industry agnostic. For example, product life cycle management, if you are say a battery chemical manufacturer or a biofuel manufacturer, you could have recipes built here on the left, which could eventually flow to your distributed control system or the manufacturing execution system. So we can really extend this particular enterprise solution architecture to across all systems. So manufacturing operations, even this ampersand, if you ask me, is a bit wrongly placed, because nowadays you cannot call manufacturing as different than operations. Manufacturing operations are really together. So over here, production scheduling, lean operations management, the entire learning that we have done when it comes to the Toyota way and the whole lean wastage when it comes to over processing and all those things. So we build on those same principles, but we sort of connect the pieces together. So right from enterprise solution, now we are diving in deep into actual processes. So be it quality execution, you can have supplier quality as a subset of this, actual production quality, or even warranty claims you could basically extend to. This quality also could be extended right down to service BOM. So a car is already rolled out, it is already out there in play, or a system is, a tower has been constructed. You could have third-party sort of servicers actually working on that. So a service BOM for a final product which was delivered several years ago, you could have the same set of data to tell you which gasket has to be replaced by what particular part, and whether should I claim back a warranty on that. So quality can be really extended. Material synchronization, because now we are talking about collaboration. So material synchronization is not just the outward finished good materials going to your customer, but also line side replacement, because there is a concept of just in time that you would have seen, but some of our clients sort of joke that we run our operations somehow in time. So we really have to sort of get away from that particular part, that somehow in time, to really just in time. Material synchronization is an important function that we cannot ignore. Then production and maintenance execution. So we always talk about asset utilization. How much is my factory being utilized? There is a several tonnage of capacity which is expected, or several cars which are to be rolled out. What is the typical availability? And again, so maintenance and production have to be synced together to really have to achieve this. And then, so this manufacturing operations management basically would be cut into these particular workflows or sub disciplines. So again, we are not touching every concept here in detail. So basically these two concepts we'll briefly touch upon. PLM as a topic, design engineering as a topic, and service BOM we can discuss separately. So these two topics, in the interest of time, I'll sort of touch upon. So we spoke about manufacturing execution system. What is the whole this MOM about, the mother of sort of MES, manufacturing operations management? So it speaks about a set of benefits which are also kind of differentiators: operation excellence, quality compliance, and sustainable innovation. So increasing efficiency. So this again is a basic kind of a criteria, but again here the main idea is business process activities. So what happened where, by whom, basically is a data capturing that we have to do, which will eventually sort of serve us when, if there is a product recall, if we really have to attribute a warranty flaw to a supplier, for example, we have to recover that money from supplier. How do you do that? You need some data to back that up. So improving again quality, this again cuts across be it supplier quality, your own production, or even the distributors. And agility. So we all speak about standardization, but we also want flexibility and agility. And both of these concepts, if you ask me, are in direct conflict with each other. How can you have a standardized process which also allows you for flexibility? So we feel that really connecting all these systems together can help you with both. So you have high standardization, so your plants, factories are running to their maximum, but you also have improved agility. So that is really so we can sort of decrease the conflict a bit and achieve that mass customization as an example. Global enterprise standards, we have a set of most of the manufacturers typically you will see would have global operations, or also many operations within India. There are certain sort of local standards you would typically cater to, but also certain standard practices that you would like to roll out across many plants. And there again, so you can have best practices which can be routinely enhanced and quickly deployed enterprise-wide scale. So we do not disturb local practices, local regulations, all the while maintaining a standard business process backbone, which helps us roll out certain best practices across enterprise-wide, because we are increasing transparency, which can help you basically identify which is the best practice in a particular system. Then again, lean compliance. So as say, be it conflict materials or product recalls, for example, if the government regulations would typically say you, if there is a fire in a particular vehicle, you typically would have to recall back a certain lot. So how much of that lot should be? Should I just recall 20 vehicles or 2000 vehicles or 2 lakh vehicles? So compliance has to be there, but it has to be quite lean and quite easy to do that. So again, expanding that interlocking traceability across supply chain operations. So that is really important if you really have to consider about not just production, but much beyond that, actual use of the asset itself. So sustainable innovation, again, a concept that we cannot ignore, whether we even if we are sort of highly efficient, sustainability again, and resiliency. So it has to, and COVID has been a hard lesson for all of us, in which again the supply chain we talked about. So supply chain, I would use a ASCM concept. So manufacturing is part of supply chain, if you ask me. And so that resiliency is what we typically have to cater to. So production of one is again, so we talk about one segment. Now it is segment of one. Everyone would need a particular customization, a highly custom product. So over here again, we feel the solution would be a production console right there, increasing transparency and sort of increasing the on time, on specification, as well as the delivery performance of a workflow. Paperless manufacturing, we have seen a business case built just on saving of paper, but that again we feel is a wrong way to sort of build a business case. We really have to build the responsiveness, the collaboration is what we can build on the business case on paperless manufacturing. So over here, it is not just about saving paper, but also the input output time. Somebody has to tag it, somebody has to sort of correct the errors and everything. So you can basically start with design to manufacturing to entire variant management, which can be entirely done in a paperless manner. So production performance we again touched upon. So we can have mass customization without sacrificing utilization. So you need not run a highly specific boutique kind of a manufacturing setup. You can have grand scale industrialization without ignoring the customization part. So this is the MOM coverage that we talk about. Each of those functionalities, each of those important functions, disciplines, workflows, departments, whatever you may call it, replenishment is important, time and labor is important, workforce productivity, skill metrics, receiving of materials, quality control, shipping, and each of these every KPI, so be it mean time to repair or mean time between failure, could be mapped. So you could have a single system or system of system exposed. You need not have many ERP terminals or a warehousing system, a different system and everything. Just last slide. So you can basically hit home if you connect everything together. So this is on my last slide about conclusion, having this particular methodic approach to sort of having this business transformation. So we can start by identifying internal organization silos, and these silos may not be different departments, even mental barriers also could be such silos. This is the way we do it. Aisa hi hota hai. This is the way it has been done for the past decade. So all those silos, basically we have to identify a clear, basic, non-biased brainstorming is what is needed. Adopt a methodical and structured approach, because many of our systems, our legacy systems, we have to build on top of that. We cannot have a shutdown for too long. So we have to have a methodical structured approach, and that, so be it human-centered design or voice of customer capturing or design thinking, you may adopt any of these sort of approaches. And align strategically over, especially now we have to look outwards. So customers and suppliers are key important here, and it is quite difficult to connect all this. But more pieces we connect, be it through a supplier portal connected to your ERP or manufacturing system, right down to a customer order which is placed. If it comes to your production order, we really have achieved something. So having an external outlook is really helpful, and again fostering a culture of communication and transparency. Especially when we start, not everyone likes transparency, because in certain ways a system is designed for that gray area. So really we have to break those cultural boundaries we see, and we have seen many of our clients actually do that in to sort of moving towards knowledge sharing and ultimately strengthening long-term partnerships. So this is all I had. We can have more discussions on the sideline. We have a table out there in the breakout area with our partner Solis Technologies. So thank you.